Okay, so what we're going to talk about in this screencast is a continuation of the arc length problem. And one thing I want to make sure I underscore to you is this point right here. Whenever you're asked to find the arc length and you're asked to find the actual arc length by hand without a calculator, there is always, always, always going to be a way to make the integrand very nice if you simplify it algebraically correctly. So I said, be watchful for algebraic machinations. My favorite word, machinations. You can go ahead and look that up. But the point is that when you're doing these by hand, the integrand, when you get to the point where you have to anti-differentiate, things should always work out nicely. Just you have to make sure you're watchful of it, of the trick. So today we saw a case where a quadratic ended up factoring, and then you could take the integrand. Here's another example, okay, when you are looking at this problem right here, if you go ahead and follow along with me, I wrote here to make note of the fact that x here is a function of y. We're dealing with a function of y over an interval of y. And what I do here for these, what I often do before I even go to the integrand is I just simplify before I go into the integrand. So I find g prime of y, I square g prime of y, and again, if you want to know how I went from g prime of y here to g prime of y squared, I did some work here to show you. Of course, you could understand that when you're doing this algebra, just be careful that you're doing the algebra correctly. When you multiply this out, or FOIL, if you will, just remember your properties of exponents. Remember that anything raised to the 0 equals 1, okay? And this becomes g prime of y squared. Now, I recognize, so here is g prime of y squared. I now put it into the integrand, the square root of 1 plus g prime of y squared. Now, if you simplify this integrand, you get this, okay, which is a factorable trinomial. It's not quadratic. It actually is in quadratic form, but it's factorable over here in blue, okay? So this is an example right here that you've got some algebra to do as you make your way to getting to a place where you can just then differentiate. So this radicand factors to this binomial times the same binomial, or the binomial squared. And of course, the square root of a binomial squared just gives you the binomial. And at this point, I can just do a dot, dot, dot. You can take it from here, okay? Y equals x to the 3/2. This is a curve that comes up a lot in arc length questions. Y equals x to the 3/2, also y equals x to the 2/3, because when you set it up, the work actually, the derivatives, and then when you square the okay, so here is y prime right here. Here is y prime. Here is y prime squared. And then here is when I put everything into the integral expression for the arc length. And look at this. How do you integrate here? You let u equal, this is a u sub, let u equal 1 plus 9/4 x. And if you want to go ahead and now that you see, you're going to do u sub. If you want to see what the resulting integral in terms of u is, you can pause me and then do your work and then check, or come along with me here. At the end of the day, I get an integral in terms of u right here. Notice how my limits of integration had to change because of my conversion equation between x and u, okay? And then, of course, here is me taking the antiderivative. And then at the end of the day, because we're not going to worry about, if this is not calculator active, actually evaluating this, you know what you just write, everyone? You just write 31/4 to the 3/2 minus 13/4 to the 3/2, okay? A couple of things to note. Your textbook, the answers in the back may not match these, because I think the answers in the back, they do simplify some, and I think they also rewrite in radical notation. But again, we'll check our work on Tuesday when I see you. So please be mindful of that, okay? And finally, I leave you with this. My latest find in the wild, crazy world of calculus memes and jokes. Who gets this? If you get it, share with share with share with someone at the dinner table sometime this weekend. Homework is posted on the teacher page. Have a good night.